Today I am going to discuss unequal length of investment decision. A firm has to choose between two projects X and Y which are designed differently but perform essentially the same function. X would involve an initial cash outlay of rupees 1,20,000 and operating expenses of rupees 30,000 per year for 4 years. On the other hand, Y would involve an initial cash outlay of rupees 60,000 and operating expenses of rupees 40,000 per year for 2 years. That means the length of the project or plant or machinery, you can say, is different. One is for 4 years and another investment is for 2 years. Discount rate for this problem is given 10%. The problem is which project should be accepted. The problem is different from other normal problems because here the length of the project is different. That's why it is called unequal length investments. One is of 4 years and another is of 2 years. Then how we will proceed to solve it? See. Okay. Solution. This is the solution. As in this case the project length is different. Before starting to calculate the NPV, means net present value of the total cash outflow, length of the project is to be made same. Only then you can compare. To understand the calculation, we have used here Excel software. Look it. Okay. This is the Excel software where the calculation has been made. The two project X and project Y. You can say plant also. Suppose two AC plants. You are going to select AC plant like that or project. For X, the length of the project is 4 years. That's why initial cash outflow. This is all a cash outflows. In this case, there is no sin of cash inflows. Only the investment cost. The cheaper one will be accepted. So this is here 0 means initial investment and 1, 2, 3, 4 years. And project X and project Y, or you can say plant X, plant Y. You have to select out of this which is the least cost. For project X, initial outflow is 120 in thousand. That means rupees 1,20,000. And every year the operating cost 30,000 for project X. That's why 30,000 first year, second year, third year, and fourth year. Similarly, for project Y, the initial investment is 60,000 because rupees in thousands, and the operating cost 40,000 and 40,000 because the length of this project or life of this plant is 2 years. And for that reason, here it is mentioned nil like that. So we have to find out the total investment required for this project at present value, and this is calculated here. The formula used, it is easy in Excel sheet to find out the present value. This is equal to NPV, net present value, 10% discount rate. You can check the formula D6 to G6. D6 means this is the first 6 to G6, and this is the present value plus the initial outflow, isliye plus C6. In this way we have calculated 215.10, that is rupees 2,15,100 at the present value or present cost for project X. And project Y, the same calculation has been made. The total cost is, the formulas is used here. C7 means C7 is this. This is the initial cost, it is added, and the total cost is 1,29,420. This is the lower from this. Should we accept Y? No, this is wrong. Why wrong? Because you have to compare the total cost for the equal life. Here the life is shown 2 years. That means again you have to purchase another plant to cover another 2 years, and that is shown here to compare. That means this figure is not to be taken for consideration of the decision for selecting the project Y in respect of total investment of the project, because you have to make the length of the project first. How it is made? The length of the project same. See, suppose the plant Y, the project Y, we have taken in two parts. First Y1, first plant, that is initial investment 60 and the life first year and second year, and it will be finished after the second year. And for that reason another similar plant or project, you can say, have to be installed this year to cover another 2 years to make the period 4 years. That means the total investment for this project will be initially 60,000, then 40,000, and second year it would be 100. 100 means 1 lakh, 40,000 plus 60,000, because you have to purchase another plant to run up to 4 years, and again 40,000. In this way you will lay out the outflow of fund. And here again the present value is calculated applying the formula from Excel sheet, and this is the total cost required for the project Y or plant Y, that is 2,36,380. That means to cover the 4 years for project X or plant X, the total cost required is 2,15,100, and for project Y or plant Y, the same function required to be performed with the cost 2,36,380. That means you have to compare to select the projects. This 2,15,100, that is the total cost project X, and this is the total cost for project Y, and you have to select the minimum one. As out of these two, the minimum amount is this, which is against X. That's why choose project X, since the present value of its total cost is lower. I think it is clear. That means in this problem where the life or length of the projects is 4 and 2, the selection of the project is X. You have to select the project X as it is cheaper than project Y. I think it is clear. Now next issues, that is annual equivalent value method, or you can say annual equivalent cost. What is this? In this case the project lives are uneven, 2 years and 4 years, the present case. So it is easy to make them equal by extending both to 4 years. However, if the project lives are 3 years and 8 years, say the life of the project X is 3 years and the life of the project is 8 years, or vice versa, then the investments will need to be repeated until they coincide at 24 years. After 24 years only 3 into 8 will match the same length. This would be a long and tedious process to obtain a solution. In such situation, it is easier to use the annual equivalent value method. How you will do it, that I am going to discuss now. I think it is clear. Again I am repeating, as it is 2 and 4, that's why it is very easy to make the equal length of the projects. But if one plant or project life is 3 years and another is 8 years, or say another one is 2 years and another is 9 years, then in that case 18 years required to wait to match, and it will be a lengthy calculations. In that situation, what you will do to take decision very easy way, that I am going to discuss, that is called the annual equivalent value method. Now through Excel sheet I am again going to discuss how it will be. First I am going to show the calculation, then later I will show the Excel sheet. Annual equivalent value, the formula is annual equivalent value multiplied by annual annuity factor is equal to NPV, net present value. That I am going to show you through Excel sheet. Okay, go to the Excel sheet. This is the formula and how I am going to show you. Okay. Now, first of all, discount rate in this problem is given 10%. Now, annuity factor means in this way you have to calculate, say first year, second year, third year, fourth year. I am showing the given problem. First year the present discount factor will be, after 1 year is 10%, that's the present factor will be 0.9091. Okay, annuity factor. And after second year the discount factor will be this. If you use the formula, if this is the formula is given, you can check it, 1 by 1 plus 0.1 to the power to the square, because after second year if you multiply the amount of second year by this factor, discount factor, then you will get the present value, and that value is this. And this is the annuity factor for 2 years. If you add this and this, then you will get this factor. That means if the amount is same and repetition, then you can multiply that same amount by this annuity factor to get the present value. If the 2 years are considered, for 3 years, what will be happen? For 3 years or third year, the present value will be this, the present value factor, the discount factor, 1 by 1 plus 0.01, 10% is the discount rate, and this is the power, and this is the annuity factor after 3 years. And after 4 years you will see this is nothing but you have to add this plus this, then you will get this. That is done. and after 4 years the annuity factor will be this. In this way the annuity factor is calculated. Even you can calculate also by calculator. Now what is this? Annual equivalent value for project X into 3.161699 is equal to 2,15,100. Sir, why you have done this? That is, the concept is this. This is your total cost for project X. For project X, the total cost of investment for project X. Now we can consider the same amount each year will be expensed. That means the operating cost will be same AEB equivalent amount. Then if we multiply the annuity factor, the total amount should be this. That means the present total cost. You can say this is equivalent cost. If we find out the value, then you will get 67,858. The concept is, if you expense the same amount year after year up to 4 years, and if you again discounted this to the present value, the total amount will be 2,15,100. That means you have divided this total cost equally over 4 years. That means you can say equivalent to every year the total cost involved for project X is 67,850. And similarly for project Y, we have done for 2 years only. After 2 years, the total figure we have seen the given in the previous one. The present value is 1,29,400. You can see it. This is the present value 1 lakh. This is the after 2 years 1,29,400. This is 2 years. That's why to get the annuity factor, you have to consider the 2 years annuity factor. This is the 2 years annuity factor because you have taken the value for 2 years, and that's the equivalent value. That means per annum the cost will be this. That is shown inside. That is first year. Say you are expending for project Y. This is project Y, 74,572, and second year, if you expend this amount, if you discount this value to the present value at the rate of 10%, then you will get this total cost. That's when in equivalent way you can say for project Y, the year wise cost, operational cost is 74,500. For your easy understanding, I have also calculated and shown the figure that it is same. Every year you are expending, or your operating cost is for project X this 67,850, and if you discounted this at 10% and discount rate, then you will see the total cost will be this one, 2,15,101. That is due to rounding factor. Actually 2,15,100. That means you can say for project X the equivalent cost for every year is rupees 67,858, and for project Y every year you have to incur the cost of rupees 74,572. Then which one will accept? The lower one will accept, the lower operational cost. Again the answer will be same, but the process is very simple. In this case you need not to recur the project to match it a long period. You just calculate over the given figures only. Okay, so that means by this method you can select the project X as the cheaper for investment, as the equivalent total cost for this project is 67,858, but for project Y the cost will be higher. That's why you are selecting the answer for X. Your answer is same as before earlier. Now again we are moving back. Your answer as the AEB for project X is cheaper, the project X will be accepted, and the entire calculation has been summarized here. Now next, now what is the AEB, annual equivalent value, for perpetuities? What is perpetuities? Perpetuities means forever. If you run the project forever, then what will be the total cost project wise? That how will calculate? It is very simple. The formula we know for perpetuity, the net present value formula is the cost for every year divided by discount factor. This is the formula. The cost for everyone for project X is 67,857, which we have just shown, and divided by 0.1. That means for project X, if you run forever, then the total cost involvement will be 6,78,570. And for project Y, you can say machine also. That's why I have written in bracket machine. It will be, this is the operating cost, entire cost per year for project Y divided by the discount factor, then, or discount rate, then you will get the total cost for the project Y at present value. This is the net present value. That is 7,45,720. Then which one will accept? The cheaper one will accept. The total cost if you run the project forever is this, which is lesser than project Y, and for that reason invest for project X as it is cheaper. This is all about our discussion today, but one thing more we can discuss, as the project will be lengthy, that's why I will discuss in separate video the effect of inflation. As it is a long term investment, we can incorporate the inflation effect to the cash flows for decision making. That will be discussed in my separate video. Okay, so this is all about our discussion today. Thank you. If you have any problem, you will just write to the comment box. I will definitely give you the reply at the earliest possible. Thank you very much. But if you find it is good and it is helpful to you, then definitely put a like, and you also share with your friends and to make subscribe to this channel. Thank you very much.